And recording. Hello, hello. Okay, let me say hello to everyone. Hello, Gary, Stephen, Shazar, Ricky, Qbit, Mahmoud, Jonja, G_M, Mititi, Harp, Hajar, Ngasi, Bilin, Ayub, Abdu, and Nax.
You're saying hello to yourself, bro.
so I don't, so I don't get. Okay, so today we have like two topics. Wait, let me hide this one. Today we have like two topics, maths and geometry. And so I am weak in both of them, so I hope I get help leading this PLD, and we try to understand as much as we can. But like important part is like to know that this topic is not like important in like interviews, but some technique or like some tricks it's good to be aware of. So let's see what are these tricks together. Let's start. Math is foundational aspects of computer science, and every programmer and computer scientist need to have basic mathematical knowledge. Thankfully, for the purpose of coding interview, there usually won't be that much math involved. But some basic math technique is helpful to know, as you might be asked to implement mathematical operation. Thing to look out for during interview. If code involves division or modulo, remember to check for division or modulo by zero case. So for example, let's see. Check for modulo. Where is it? Okay, so like division or modulo by zero in Python. If you're trying to divide number by zero or perform a modulo operation with zero, it will rise as zero division error. To prevent this, you should always check if the denominator is zero before performing this operation. For example, check here if it's equal zero, then like handle this case. Check for and handle overflow, underflow. If you are using type language like Java and C++, at the very least, mention that overflow, underflow is possible and ask whether you need to handle it. Yesterday in the binary topic, we saw something like this. We know that like we saw that Java and like C++, they don't react the same way as like Python. For example, let me try to open that document quickly. Binary. Okay, so we saw it somewhere here. Overflow problem in Python. So for example, in Python, so for example in C++, if you did like int max and you add one number, it's gonna flip to int min. It's gonna become minus because there's overflow. The C++ example Java, it handled the overflow, and for Python, no. If you reach the max number, for example 32-bit, so if you say in 32-bit, this is the max number decimal you can reach. So if I add a plus to this, it's gonna become int min, right? Because it's over the limit. But in Python, if you're gonna add one to this max 32-bit, it will still take it and it will rise that number, because in Python it doesn't have integer like a fix as other language. Let me share this.
Can you zoom?
Yes.
Zoom.
Let me zoom. So like in Python, it doesn't handle the overflow. You need to do it yourself, and like it will just keep rising this number as much as possible in the memory. There's detailed explanation here. I will share this link here if you want, like, check it out. It's good to be aware of it. And yeah, let's continue. This one is also I shared. So for example, overflow, underflow, there is one thing we can handle in Python is like for float, handle integer of overflow. However, in language like Java and C++, you need to be aware of the maximum and the minimum value that a variable type can hold. So if like you reach the maximum of 32 bits, you can just like add one more above it. Like you need to increase the space. If calculation results in value outside this range, it can cause an overflow for too large value or underflow for small value. In Python, floating point number can still experience overflow and underflow. Here an example of how you might handle overflow with floating point numbers. So for example, I have A and B, and now I want to check if it's gonna have overflow or like underflow. I think they are like using this variable to check if the result is greater than this. So we have overflow. If it is less than the negative itself, then we have underflow. Okay, it's good to be aware of this. There's many other what is called like thing to be aware of.
Edge
like
cases.
yeah, edge cases. For example, negative number and floating point number. Always consider how your code will handle negative number and floating number point. Floating number point numbers. For example, the square root function is undefined for negative number in the real number system, and the floating point number can have precision issues. Save. Okay. Save square. Now we're gonna handle the 0 case. If number, then okay. Okay, good to be aware of this. Let's see what other thing. We can hide this. Okay, consider negative number. This is what we saw. Corner cases, division by 0, multiplication by 1, negative number, float. Now common formula, check if a number is even, sum of 1 to n. Let's see also like more. So like check if number is even, we can use like modulo. Sum of 1 to n number, we can use this formula. N plus 1 multiply by n divided by 2. Sum of geometric progression. I have no idea what that means, but I'm sure someone here maybe can explain what this means. If someone please, like any points you wanna explain something here, pick up the map, like the mic, and just explain it. But the goal here is to be aware of this stuff. Then each one of us can like check it out more deeply. As the host of this PLD, I have luck on this math and geometry, so I can't like explain in details. So bear with me. Permutation of n. This number of ways to choose to choose and arrange key item from n item. The formula is n. I'm like reading Chinese right now. N wherever it's factorial divided n minus k factorial. Where okay, so what is this, like a factorial? It's called factorial.
Yeah.
Factorial denotes. Okay. Okay, so
Oh,
like
it's N. You say it really loudly. N.
n. Okay, like can someone explain what this one does? If I'm gonna like read
That's permutation. So you are looking for the number of ways you can get arrange an item.
arrange.
Give us an example, bro.
Like for example, how can you arrange A, B, and C? How many times can you arrange A, B, and C? So you have A, B, C, you have B, C, A, you have B, A, C, you have C, B, A. So you have multiple ways to arrange those three values.
Okay,
so you can use this formula to get the number of ways you can do that arrangement.
Okay, that's amazing. So like if I have like 3 items, I can see how much like I can, if I can like do A, B, C, C, B, C, B, A, like I can get all the possibilities, right? B, A,
Yeah, all
C.
the possible
Okay.
arrangement.
Okay. Yeah. That is amazing. I wish if I can go back and like study math, but it's too late now. Maybe I will try later. Combination of n. This is number of ways to choose k item from n item without regard to the order of selection. Okay. Is this one close to this one? Combination?
And they're in the same category. But combination does not regard the order of selection.
Okay. Okay. I see. So this one is order, this one is not order.
Yeah.
Okay, there is also more, but we can like skip this. If you want to like check it in documents, you can find it here. So let's see what else. Technique. So we have multiply of number, comparing float, fast operator. Let's see comparing of number or like multiply of number. Multiply of number, the modulo operator can be used to check if number is multiply of another number. If x modulo y equals 0, then x is multiply of y. Okay. Now comparing floats, due to the way floats point number are represented in computers, they can have rounding errors. Therefore, when comparing two floats, it's better to check if their difference is within a small range, epsilon, rather than checking if they are exactly equal. Anyone understand this or like have idea about this?
So I think that would be like, for floats, they can go as far as the number of decimal points can be very large. And then, for example, you want to compare 1.00 with 1.00, but you don't have a limiter on the number of decimal points. You can go as far as 20, 30 decimal points, and those decimal points might have values after the zeros. It might have values depending on how the computer does this solving. So when you do a comparison between the two, it might actually give you that is not that it might say it's not equal. Meanwhile, you just want to check if 1.0 is equal to 1.0, but it might show it's not equal. So if you limit it, like for example, this epsilon is like a mask, like how we did for Python. So
Yeah.
it will stop it at maybe 6 decimal points, 2, 3. So it will just use that one only to match what you need to. So if you want to check if they are equal, it will only stop at maybe the third or fourth decimal. In this case, that would be like the 7th decimal point, I think. Then
Okay.
to check between the two. So it's more like a mask.
I see. Okay, we can see what else. Fast operator. Fast operator, some mathematical operation can be optimized using technique like fast exponentiation or binary search. Fast exponentiation. This technique, also known as exponentiation by squaring, allowing you to compute x power of n in all log n time. So fast power n modulo, and then we have like recursion. Okay, anyone can explain this? Why is this called fast power? Like, is it like perform better? Some mathematical operation can be optimized. Yeah, so like this is optimization of power. Okay. This is same, but this one is done by search, binary search. Okay. Oh god, this is going deep. Okay, let's go back. So Now we saw maths, okay? Let's see, do we jump to essential question, or like do we maybe ask ChatGPT to explain more, or like I think we can like jump to one of lead code problem, and then through which we can learn more what's possible to solve it. And yeah, if we fail to solve it, it's okay. Like here, we are here to learn, like no one is perfect. We can watch video solution or check solution here and learn it. The goal is like, yesterday you didn't know ABC, today you know ABC, and tomorrow you know DEF, and each day you grow. Now, enough talking. Let's jump to the power xn. Let's see what it is. Implements power xn, which calculates x raised to the power of n. Okay, implements. So we need to create it ourselves, not use like the built-in. Input is x, we give it 2 float number, and n, let's give us this. Example 2, input x, okay, to n. Okay, for example, for me, I forget what's power, how it work, and stuff like that. So probably I need to watch this video. Let's watch it together, see how the power work, then we can solve the problem together. Let's do it. Change window. Where are you? Here you are. And then max volume. And yep. Let's see what is this power. Okay, sharing screen. Hope you guys here.
Hello everyone. Do you know the area of a square or volume of a cube? Yes, you got it right. The area of a square is side square and volume of a cube is side cube. If the length of one side is a, then what will be the area of a square? Yes, it will be a square. Or suppose if we have a cube of length a, then what will be the volume of a cube? Yes, it will be a cube. Friends, if you will see carefully, there is a number which is at the upper right corner of a. What does that mean? We often came across this kind of numbers, but have you ever thought what exactly it indicates? Well friends, these numbers are nothing but the exponents or index, or we can say power. So friends, today in this session we are going to explore more about the exponents. Okay friends, let's have a look at these numbers. In first, there is a single digit 2, next 2 plus 2, next 2 plus 2 plus 2, and so on. So friends, for this what we can do? If we have 2 plus 2, then we multiply 2 by 2, that is 2 into 2. Similarly, if it is 2 plus 2 plus 2, then we can write it as 2 into 3, and so on. At the end, you can see here, if we add 2 for 10 times, then we can write it as 2 into 10. This is known as repeated addition. Now, if it is asked to add 2 for 30 times or 2 for 50 times, then how you are going to write it? 2 into 30 and 2 into 50, right? That means for repeated addition, we can use multiplication. But what happens when we have repeated multiplication? Let's have a look at these numbers. Well, at the end you can see 2 is multiplied 10 times. What if it is asked to multiply 2 for 50 times? Are you going to write 2 for 50 times? Well, it is very time consuming and tedious process, and it will be very difficult for counting and understanding. Therefore, to avoid this lengthy operation, mathematicians have introduced this method. You can see here, if 2 is multiplied for 2 times, then it is written in the form of. This mathematical operation, or you can say form, is known as exponent or power. The exponent is placed to the upper right corner of the base number and signifies how many times the base term is multiplied by itself. For example, here you can see 2 is multiplied for 5 times and 5 is exponent as it signifies the number of times the number 2 has multiplied by itself, or you can say 2 to the power of 5 or 2 to the 5th power. Similarly, if it is asked to multiply 2 by 2 for 30 times or 2 by 2 for 50 times, then how you are going to write it? 2 raised to the power 30 and 2 raised to the power 50, right? That means for repeated multiplication, we can use exponents. In general form, if n is a positive integer and a is any real number, then a raised to the power of n corresponds to repeated multiplication. Friends, there is also one more interesting thing about multiplication and exponential. Let's see what is that thing. Let's have a look at this image. Well, you can see here the number of boxes is increasing rapidly in exponential as compared to multiplication. Here, exponentially means if something is increasing or expanding at a steady and usually rapid rate, then it is expressed using the exponents. We can even observe in our daily lives like population grow exponentially each day or growth of bacteria increases exponentially per hour. Similarly, exponents are often used to describe how much memory or RAM a computer holds. For example, 1 KB equal to 2 raised to the power 10 bytes or 1024 bytes. Or mass of the earth is almost 5.972 into 10 to the power 24 kg. Also friends, do you think square root of 2 has an exponent? How do you write square root of 2 in exponential form? The square root of 2 is written as 2 raised to the power 1 divided by 2. Similarly, the cube root of 2 is written as 2 raised to the power 1 divided by 3. So here we can see that 1 divided by 2 and 1 divided by 3 are nothing but the exponents. So till now we have seen that what exactly exponents are. Let us solve some examples. What is the value of? It's simple. We just have to multiply 6 into 3. Oh wait, no. If we see carefully, 3 is above upper right corner of 6. So here base is 6 and exponent is 3. That is 6 is multiplied by itself for 3 times. Therefore 6 into 6 into 6 equal to 216. What is the standard form of? As 9 is multiplied by itself for 4 times, therefore 9 is base and 4 is an exponent. Now try to solve the next question on your own and write your answer in the comment box. So friends,
Okay, I guess now we have the power to start this Let's code. Okay, how we can do this? Let me open Excalibur. Maybe we brainstorm and see how we can do it. And first, let's take this example right here. Like take them, 3 of them. How we can implement our power? How we can do that? So implements power x n. We calculate x raised to the power n, like without using like the built-in. Okay, let's brainstorm how we can do that.
I'm thinking you can just multiply x by itself n times.
Loop.
Loop n times during each phase of the loop, you just multiply x by itself.
Okay. Okay, we can do that.
So you can use recursion anyhow you want to do it.
Okay.
Or iteration in Python, in C will be different, but I don't know, it's easy. I don't think it will be that hard.
Like the recursion, it's not gonna be hard.
No, recursion or iteration both will be very easy actually. It's very simple.
Okay, let's do it with the loop. I think it will be easy to see.
Yeah, the loop is okay.
Okay, so basically, if we're gonna write it as pseudocode, so we're gonna do for, and what was the code?
It's I. It's N.
Like the full.
Mhm.
Okay, so so if we're gonna do it with loop,
I'm thinking let's start with I equal 1 and while I less than or equal n. You just x equal x multiplied by x. Then x every loop it will change and you just return the x.
okay, so I equal 1
Yeah.
and for
A.
for A. Okay,
I
so
thought,
X
she
is
said I thought she said while loop. Oh really? I thought it's while loop she was
okay.
talking about.
Yes, while loop and each time you increment
Yeah,
the I till it reach the n, till it equal n until while I less than or equal n. You stop when I is bigger than n.
What
Okay,
do you do when it's negative? If I could just ask.
wait, can you repeat?
Say she used a while loop there. While I is, I don't know what she said. While something I less than n or so. I don't know.
With negative,
talking
you said
about-
Ningas. Is it
Yeah.
like
Are we handling the negative case or are we just moving with the positive case?
okay? I'm not sure. Maybe we can like do the positive and then if it was, is it? I think the negative is gonna be the same value. Maybe we just add negative at the end.
No.
No, it's a different how to say procedure. Yeah, let's do the positive and then we'll handle the negative case.
Okay. So I'm still a fog to see how this gonna work.
While I less than or equal to N.
While I is less equal n. Okay, yeah, so we can loop n time
Then you just
and then
multiply the floats by itself.
okay,
So,
let's put this
that'll
maybe
be
in
X.
some
Yeah,
rips.
we should keep a variable.
You
We should keep a
have a
variable
result.
to
A results. Yeah.
Result
Correct.
equal x the first time,
1.
x to 0.
Exactly. X. That's correct.
Result
Result has to
multiplied by
start from
x
the first
Like
number.
and you
Yes.
increment I.
So that means it will be less than then, less than n because of that. The first number has been taken into account.
Can you repeat, Pascal? It should be what? Less
I
than
mean,
n. Error,
what
this
she
one?
said is you should start with x, set the result to x. That's what she said, and that makes sense.
Here.
Start with first number, yes. So if you're starting with that, then you multiply recursively, iteratively. So that means that this equal to has to be less than n then.
Yeah, less than n, not
Less
I
than
think
not equal
not
to n.
less than n.
The condition of the while.
Okay, please like
And
try
just
to
return
explain
the
this
result.
slowly because my CPU is very slow. Okay, so
Yeah, deal with it.
why we did remove plus from here?
Because
we
the
already
result
have
is
the x
already
in
X.
the first iteration. The result equal x.
Oh,
So
okay, I see. So we
if
like
we set
skip one
result
turn.
with 1,
Okay.
it will be equal. Pascal said it correctly actually.
Okay, so we skip that because we already put it here. And then we increment 1. Okay. But, okay, is this should start from 0 or start from 1? If we said like in 10 time.
0.
From 0?
If I is less than n.
So this is 10, and this gonna stop in 9. So 0 to 9 is 10, but we have 1 already here. So I think it's correct, right? Because this gonna loop just
We
9
can
times.
try to, let's say, x equal 5 and n equals 3, and try loop it. It's like just see if it actually works.
Equal 3. Okay, what should this give results? 5 power of 3?
That should give you 125. 125.
Let's try 2 to the power of 3 is 8, so it's much easier.
Yeah, use the smaller number. That will make sense. Yes.
2 power. Okay. Okay. What's this one?
8.
8. Okay, my brain is shut down, so please don't judge me. Okay, so E is gonna be 1, then res is gonna be 2, while 1 less than n, which is 3. It's gonna loop. Res gonna be x 2 2. Okay, then what's gonna happen to E? It's gonna increment to become 2. Then it's gonna loop again. Now E is 2. 2 is less than 3, so it's gonna enter. Now again 4. What is it, like 16?
4 times 2.
8.
8. Oh, it's gonna, so like 4.
I think.
Four?
I think.
No, the x,
Why-
remember, remains the
So
same.
4
It doesn't
times
change.
2.
Is
Oh,
less or
x is
equal?
2. Okay. So 4 2.
Less or equal, maybe.
Wait, can you repeat, Ayub?
I
Here?
think it's while I less or equal n.
This
Okay,
is
so-
correct, actually. This is correct.
So you're
This
saying
code
like
is
this?
correct.
I think because e equal 1, so the first is 1, the second is 2, the third is when e equal 3.
Mm.
Okay.
Okay,
when
we can-
e equal 3.
Maybe we can keep looping and see if
continue,
it's gonna
continue,
work.
okay.
Yeah.
Okay.
So x is 2. So
Yeah.
we have 4. 2 is 8. Now res is 8 plus 1, and e was 2. It's gonna become 3. Now we're gonna loop. It finished this loop. It's gonna go. It's gonna become 3 less than 3. It's not gonna enter, and we found our results. We can return the result.
Two, yeah.
Okay, so it's working, I believe. Wow, I'm smart.
Yes, that's one. That's one case we've
Yeah.
handled. That's the positive
You are,
case,
com-
right?
you are the compiler now.
Okay.
But we haven't handled 2 other
Oh,
cases.
the negative.
The negative and the 0 case.
Okay, let's see the negative. Let's choose, for example. So, is it like the negative x or the negative n?
If n equals 0, it will return 1, if I'm
Yes.
correct.
Is
So
n
we
equals
just if
0?
condition, if n equals 0, return 1.
Okay,
Assembly.
Yes, that's correct. Yes.
so if n equals 0, return 1. Okay,
Absolutely. You could also insinuate that if x is equal to 0, I suppose, you can just return 0, if I'm not wrong.
But it will still do the same thing, though.
Yeah, it's simple.
Even though x was 0, actually, it will still give you 0 because it's multiplying by itself 0 0 0. But it's okay.
Yeah,
You can
but
still.
Should we
But
go into
not to-
computation?
Because of time, yes. Because of time, yeah. I get.
Yeah, they just do it so we look like smart.
Okay.
We know math. Okay, 0. What else? the negative numbers. Now the negative, there is two cases. This one, negative x and negative n.
Now don't worry about
Are like the
negative x.
same?
We should just worry about the n, the
Don't worry about
exponential.
negative
Yeah.
x. You just have to worry about
Exponent.
negative n.
Yeah.
The exponent.
Because
Yes,
x
exactly.
is multiple.
That one is just like you're saying 1 divided by whatever you are doing. Yeah. So
Okay, so you're saying that x, if it was negative, the result's gonna still follow. But if
Yeah.
n was negative,
The
but-
structure is changed.
okay. N, if it was negative, where it's here. This condition.
Yeah.
This condition is gonna be affected.
It
Because
won't- it
this is
won't
gonna be
enter the
false.
line at all even. So we need another condition, an if condition for the negative. I don't know what happened when the power of negative. I don't know how to calculate it actually.
It's divide
I
equals.
think
no,
we
it's
can- we
divide.
can
You just
divide-
divide by the. But you just divide by one
Yeah.
divided by whatever your result is. So
Yeah,
if you're
check.
writing the condition there, you have to check if
Yeah.
the n was negative.
You need to one.
You probably want to put it where the I equals 1 and above the I equals 1.
Yeah. It's one.
Okay. Above.
Divis x.
Yeah, that
Yep.
I equals 1 line. Yeah, that line. That the whole thing encompasses the positive.
Yeah.
Wait, why above this?
Because you're going towards 0 in that particular case.
You can take
Um,
like x equal 1 divis x.
It's
X.
a different direction you're going in.
Yeah. X equal 1 divis x.
Okay.
So just like this.
So the only difference is we change the x.
No,
from-
no. This is no. Sorry, please. I'm confused at this point.
No, it's
What about?
you see. You wanna go, Pascal?
Okay, go ahead. No, go ahead. Talk. Go ahead.
Yusuf, can we check what happened when the n is negative? Because I don't get it yet.
Okay, in this case,
when the n is negative, right?
When the n is negative,
In
you
each iteration, you're adding
It is just
1 to that
change.
negative number, but you're headed towards 0, I believe, right? The condition is almost the same. All you have to okay, let's do it this way, yeah. Let's put the positive case in how to say in an indentation because we've handled that, right? So let's do n greater than 0,
n
and then we
greater
can.
than zero. Okay, wait. Can you repeat
This is-
in here?
No. Let's just change the case instead of less than. Let's just handle because we already handled the positive, right? Let's make this first if statement for the positive case when n is greater than 0. So when n is greater than 0, basically everything we've done before from the I equals 1 all the way down to the returns will apply.
Exactly.
Yeah.
And then let's then handle the case when it's negative.
Okay, my brain
So-
just
So the if n
So I think
smaller
it's
than
just to
0,
write a condition. Yeah.
just change it to n greater than 0.
which one?
No, that line.
Click on
Yeah,
the
that's
Greater
it.
than n greater than 0?
So when
Yes.
it's positive, yeah?
So
and then-
you have to remove the second line.
Yes.
You have to remove that. Yes, you have to remove that line.
And
yes.
then-
So that
yeah,
means the
indent
else part.
everything below.
From I
Okay.
equal one,
Okay, so
put it
this
inside
gonna
there.
be like this.
Yes.
Okay, and then we handle the negative alone.
Yes.
No, I
else.
think the return also has to be in its own if and its own condition as well.
We can
We can
reuse it.
Because
Can name,
Okay,
we can
we
name
I
in
mean,
the
if
if.
it's gonna finish this, it's
okay.
gonna return, right?
Yes.
because it's different result actually, anyways.
Yeah, but like it
You can tell.
can't enter both of them. Either it's gonna enter this or this.
Yeah.
Okay, yeah. I get. Yes, it's true. Right.
So let's see. What we're gonna do here.
So when
By
it's
the way,
next
if it's easy
time-
for you, like Ningas or someone else, I can share the link and you guys can like type directly. It's easy.
No, go ahead. You're doing well. You're doing
Okay.
fine. Go ahead.
Just
So-
in case if you wanna have control.
No,
Oops,
no.
not again. Oh my god. Stop session. Thank you. Okay, let's keep going.
Okay, so it's essentially the same kind of logic, but as it was stated before, you're dividing when it's a negative thing. So it's essentially going to be the same thing, where I is going to start from the -2, but at each iteration, as we add a 1 to it, the condition for the while loop is going to be that the I be less than or equal to 0, I think. And then the res, instead of multiplication equals x, is going to be divide equals x.
Okay, I'm not following. Maybe take it step by
sorry,
step.
please. Yangasi, why can't we just calculate it normally like this, then return 1 divided by results?
Yeah.
As simple as that.
When n is less than O.
You understand? Just do it normal, the way it is. Then, sorry, Musif, are you there?
Yes, I'm trying
It's
to
just to repeat everything. Just convert the negative n to positive. You use the same while loop, the same concept that you have used before.
But
Yes,
can
that
someone
concept.
explain, like, when you are dealing with negative number, right? So in
When
the
you're
positive
dealing,
one,
when
like,
you're dealing with negative,
we're multiplying, right?
yes, it's still going to be multiplication. But when you're returning the result, it has to be 1 divided by the result.
Oh, okay. I see. So we just
-1 times 2 raised to 2.
We're gonna do 1 divided on everything, right?
Yeah.
1 divided. Well, for me,
so
I'll
why
just
not
say
do this and just divide
Right
it?
in the negative. If he's saying it's 1 divided by the result, so you're saying 2 to the power of -3 will give us 1 divided by 8.
Exactly.
Yes, 1 divided by 2 raised to the power 3. Exactly. Correct.
So we can just like keep the n as positive or negative as a flag or something, and just calculate it directly as positive and check if it's negative. We just divide the result. Just
Yeah, exactly. That's a faster way to.
Oh, okay. So we can keep
use
this.
one loop. Yeah, we only use
we can
one
just
loop. We
can just use one
in
loop.
this
Just
condition,
check for
there is
n.
a flag. We use a flag. If the n is bigger than positive, we just keep the flag true. If it's negative, give the flag false and multiply it by itself to be positive.
Perfect.
Not multiplied by -1 to be positive, and just keep the loop going. And in the end, check the flag. If it's a flag is tell us it's negative, we know what to do.
Okay, so here we do like absolute, maybe?
Not
No.
absolute, just multiply the n by -1.
-1. Yeah, but it's okay. It's also correct as well. Absolutely.
Wait, like by 1 is like how to make it positive?
By -1.
Multiply by -1 would convert it to positive. It's the same.
-1.
Like,
Not why, not
But like absolutes do the same, right?
Easy.
If I
Easy.
get
Easy.
ABC. Yes.
Take it easy. First, you need to check if the n is less than 0. You need to make the flag false. First, you have flag. Flag is true or false. True if the n is bigger positive. False if the n is negative. So you know what you're dealing with. Then you can change the n.
Wait. Let me understand this. So we have negative case and we have positive case, and this code right here gonna be the same for both case, right?
Yes.
Right.
Because we will change n to positive.
Okay,
But
so we can like
we will check if n is negative. We calculate it directly. No need to loop or to do a lot of different things.
Okay, so the only difference is the result. If it is positive, we're gonna return results. If it is negative, we're gonna return 1 on the result.
1 divided by result.
Right?
Exactly.
Yes.
Okay. So we can check at the end, right?
I'm saying use the flag.
That's where I'm meant to check.
Like we can just check at the end, like check if and like
you will change n or I don't know.
Like n, we can just do absolute n. So like it's gonna be always
I understand.
positive.
Yeah, I understand what Musib is saying. Yes, that can work as well. Yes.
So like if this absolute n is gonna be always positive, and then we're gonna check if n negative, then we're gonna do 1 on it.
Yes, that will work as well. That's even faster. Nice one. Makes sense.
Okay. How we can do that? So if n is less than 0, then
Yeah.
results gonna become 1 or less.
Yes.
And if it is
Yes.
not, then return less.
Progress, exactly.
Why,
So you
why
either
not
lost.
just return it?
Good
Why not
one,
just
friends.
return it when you are checking that if statement instead of
Like here?
it's
No,
all
it's
the
still the
same
same
thing
thing.
because it's the
It's the
same.
same.
Instead of saying res
Oh yeah,
equals
true,
to
true.
1,
We can actually
just
do like
return.
res if this return if it is true, it's gonna return res. If it's not, it's gonna return
Else.
something like
One.
this. Else?
Yeah, it's
Yeah,
also okay as
but
well.
also this if condition will make it work because in both cases you just change the value of the result and return it. So whatever is easier, both are the same.
Yeah.
Now this is elegant. Like it. The fewest possible lines, right?
I think so.
Exactly.
But I'm not
Depends
sure
on
if I
actually
write
writing
it
it
correctly.
correctly. You need to write it correctly. That's what I'm saying.
Oh, something missing, but I don't remember what is it. Is it? I know you can mix
Else,
if
else. You're mixing the
else.
else. If this,
Here.
this, then else, this. Yes, nice.
If
Exactly.
and else. Okay.
Yeah.
Okay.
Else,
Yes.
not yes. Month if you're
It's like
Return
Okay.
range
Okay.
one
you
of
have
the
to
range.
revert it, I think.
So it's written this if true.
One over
No.
raise.
Oh
Return
yes,
one.
yes. So like if it is true, it's written this. So
One
this
divided
probably
by
should be okay. Let's do one
Yeah.
res
Okay.
res
Yeah,
like
Yeah.
this.
Yes.
absolutely. Absolutely.
So if someone
Yes,
is not
correct.
like familiar with this, so we're saying like return this value or this value. So we're either gonna return this or this depending on this condition F. If it was true, it's gonna return this. If it was false, it's gonna return this.
Yeah.
Why don't we do that in the first two if statements, if I may ask?
Which one?
No, I'm
Oh
just playing.
yeah, we can do that.
The conditions are not the same.
Okay, we can do that.
You can have the if without the else, right? One if n is equal to 0.
You know, can you start with a return statement?
I think
That's the problem.
it's the same.
Return 1
If n is equal to 0.
if n equal to 0. I guess
And then
just like
boom,
this.
we saved ourselves a line. Yeah.
Yeah, okay. Return as 0 if x equals 0. Hey, look at that.
Nice job.
Okay.
I think f equals 0 or return 0. We don't need it.
Yeah, we don't need,
Because-
but
It will save us
it's gonna
computations.
skip. Yeah, it's gonna
Say our
skip
n
this one.
is say our n is 1 billion or something. You don't want to have to go into 1 billion computations to get to the 0 that you're just going to be on.
Did not enter the right. Okay. It's trying.
I don't know if there's some kind of optimization Python might do in the background, but
Okay, let's see this this magical formula. Okay, let's start. Run. Expected else after F. So
Exactly.
else
Exactly. The syntax means the full syntax. So else what? Pass. Okay, nice.
Pass or none.
Okay, what's happened to pass? Is it not working? Or maybe I know there's something pass like
You need
this.
to write it down the same way before.
The statement maybe.
Just write it blockwise.
let's abandon that thing.
Okay, it's good. It's good try. It's good try. Okay, run. We do it C style. Oh, let's go. Let's submit. Nice work. Nice work. Let me clap. Let me clap. Where's the clap? It's pass. Nice.
Congrats, guys. Congrats.
Nice. Oh wait, we have some problem.
Take it too long.
We have this.
I think we have to optimize.
Overflow.
Time limited
Maybe use
expect. Oh, we
fast
didn't handle
operator or something.
overflow. Maybe that's the reason. But like, I don't get it. So they put x as this number, and they put this big number. And
They are raising to that number, so we are going to multiply that number of times.
oh my god, that is a lot.
We haven't handled.
So we have to compare with int max or something. I don't know.
Did we handle?
We'll have to do maybe fast operator or something.
Maybe the
Check
while loop needs
the.
something. Maybe this ABS is not working fine.
No, what's
No, that's
happening
fine.
is that we are multiplying that number of times. It's too large.
For the memory.
Yeah, it takes so much time.
It's taking a lot of time to multiply.
So what's the expected result? Sorry.
And check the interview
Yes.
in that manual. There's something called fast
There is something.
operator.
There
At the
is
bottom.
something for overflow. I think so. Overflow,
No, it's not an
underflow.
overflow.
No overflow.
Time.
Negative.
Fast operator.
This one. Fast
No.
operator.
Yeah.
It's here somewhere. Okay, this one.
Yes, this one. A fast way to do power.
Fast power.
To do it
We're flooring it.
in log of n time. So
Okay. Okay, so this is the same solution or like the same problem, right?
It's recursive
Use-
though.
Yeah. Okay, but like how we can improve our like where is the so the problem we know that we have n, which is gonna make this while gonna like keep turning for a long time.
It's a time issue.
Yeah.
It's taking way too long.
Yeah, like this number.
Yeah,
is
it's not
crazy.
like it's an output problem. It's
Yeah.
time.
So like how we can
Optimize the time.
optimize it? Yeah. Is there a way to escape or like? Maybe we
It
can.
was a medium problem for a reason, yeah.
Yeah, we can like ask ChatGPT and see what are other techniques to optimize this.
Yeah, I think it might be something with exponential. There's a way we can go through it without having to go through the entire loop.
Oh.
Is there a mathematical equation for that? Is what you're saying?
Yeah, the way I'm thinking about it is since we are going through the entire loop and multiplying it like let me use for example 2 raised to the power of 10. We are going to multiply 2 times 2, which is 4, then continue like that. But if there is a way we can multiply, we can jump over some of the multiplication. That's just what I'm. That's it.
Yeah, that makes sense. Because essentially, right, 2 raised power 10 to, let's say something like 2 raised power 20, for example, right? 2 raised power 10 times 2 raised power 10 is going to give you the same thing. So like instead of us having to go through the whole thing, if you calculate it halfway and just multiply by 2, still gives you the same result. I think something like that, right?
Okay.
like memorization, like
Yeah, partly memorization, partly it's just something like exponential. So the next time you are coming to multiply, you are increasing the number you are using to multiply.
Okay, I see what you mean. I think, for example, if you wanna do like 2, like how to say it, like so instead of like doing 10 time, I can do just like 2 5,
Yes.
right? Because they are the same.
Yeah.
So I'm saving time.
Yes.
And then maybe this 2 5 I can do like 2, or like I can split this on 2. Yeah, but like how to do that? Is that like log in something? Okay. Let's ask ChatGPT how we can do this. How we can optimize this solution. Give me 5 technique.
Make it on this. Okay, no problem.
So exponentiation by squaring. This technique reduce the number of multiplication by using property that x power of n. Is this what you did mention?
Yeah, something like this.
Okay, the second technique is built-in function. We don't want that. Optimized loop. Wait, what? Instead of using a while loop, you can use for loop and to directly iterate EBSN time. This more consistent and easy to read. But I don't think this is gonna change anything in the code.
Yeah, it does not change anything.
Wait, but maybe it will. Let's try it.
It's readability.
Most time, ChatGPT gives us some funny solutions. You can try it anyways.
Right.
You just, I'm telling you, just mess you up.
Okay. While loop is better. Other one. Okay. Optimize loop range bitwise. Oh, bitwise. Use bitwise operation for checking n is even or odd. This can be more efficient than the model operation. Okay, I think this is... Yes, go ahead.
Ask it to give you an answer with using exponential.
Okay.
Yeah, I think that's the first one.
That was the first one, the exponential formula.
That's the one I think that might solve.
Let's try to understand it.
I think this one is similar to that fast operator. So the idea behind this is like we're splitting it in half, and we do all the evens first, then we do all the odd next.
So the exponential by squaring.
I mean, a way to do that, right, would be...
Okay, yeah, this is exponential by
squaring. So essentially...
Yes, go ahead, Shadow.
Yeah, so I was just saying, the idea ChatGPT said the first one, right? So I just checking if n is even or odd. So we'll know if we are dividing it by 2 or subtracting 1, then dividing it, then multiplying by itself once more. So like give us the solution. I don't know. Yeah, basically same thing. But this is using recursion. Right, yeah.
Let's ask him
basically same thing.
Recursion. Literally what he's saying by square method is an algorithmic technique for efficiently calculating exponentiation, particularly for large exponents. It is based on the observation that if n is even, then x power of n can be expressed as x power of n divided by 2 power of 2, and if n is odd, then x is power of n can be expressed as x power of n minus 1.
Yeah, that makes sense.
Okay, we can try this. So this is without recursion. So first we check it's 0, then if it is less, if it is negative, we just put 1, we divide it by x. Wait, what? Why I did this one?
It's essentially...
They're doing it before entering into the loop.
Okay, before we... Okay, so for us, we did it in results. We can keep it in results, right? We can keep our technique and try to do this. So what we need to implement is like check if it is odd or like even. It's 1. 1 is even or odd? Odd, right?
1 is odd.
1 is odd.
It's checking for odd.
Then results, and if it is not,
multiply it.
this is the norm. I am confused. Can someone explain?
So if it's even, what happens is that it squares it, but then it slashes n by 2. So you are skipping a number. So you are doing n divided by 2 each time.
Okay. Results. Okay, how we can implement this to our code?
Copy and paste.
No, it will be nice if we can like leave our code same and just implement this part. So I think everything gonna change this part right here, right?
Yeah, that's the main part that needs to change.
Okay, can we keep this the same?
Okay, so they're handling the n greater than 0, right? And ours was...
Yeah, I think we can keep that the same. I think we can.
Yeah, we can remove the I, since the I has no...
Yep.
How to say this anymore, and then yeah, we make it the n greater than 0.
Okay. Now,
well, if we are doing that, that means we need to undo the n less than 0 previously as well.
No,
Like
No, I think he handled,
returning.
because if you look at where he
it is
said
less
n
than
equals 2
0.
minus n, look at where he changed it actually. Okay. Yeah, I think I get what you're saying. Where he divided by what divided, he didn't handle the negative part. That's true.
Because currently the loop will never run if n is
negative.
less than 0.
Where he said n equal n minus 1. Yeah.
No, it will n equals n minus 1. It will change it. Yes, it will change it at that point.
So the first if statement ensures that the n is always positive, yeah?
Exactly.
Yeah.
okay.
So
I guess
we'll have
it
to
will not
implement
work
it.
like this.
So there's nothing checking. There's nothing checking to see. We can't get results for negative power exponential. I don't think I'm seeing any.
We can. Like, see the if statement. If it is less than 0, it divides it like 1 divided by the number. So we get like the value, the actual value. Then now do the power for it. So essentially, the same thing we are doing, but now we are doing it before actually getting the power of the value, because essentially it's still going to give us the same result at the end of the
Okay,
day.
yeah. It's gonna keep. Yeah, I get the point now. Yes, exactly. It's true. It's true.
So I think we should implement that in our code also by...
Okay.
I don't think so, because we have already done it in this return statement here.
We will change this, I guess. But like, okay.
That while loop only functions if it's a positive, and you have to ensure that it's positive before it enters the while loop. In that particular example.
Okay, let's try it. So this one, we're gonna take this. So before we enter, I guess the code is gonna change all if we did this, so we don't need this. So maybe we just copy this and test it if it's gonna work.
Yeah, but we need to understand this. I think you need a PhD or something. I don't know.
Especially
I feel you might still get the time exceeded. You might still. I don't know. Just try it.
Let's see. Okay, submit. Okay, it did accept it.
The reason why I think you don't get the exceeded is because you see the n is getting divided by 2 there. So you're essentially logarithming it, if I remember.
Let's see.
So now the question now is, can we like elaborate on the while loop? Exactly what's going on in there? Why we're dividing by 2 every turn, and how that exactly works? I think we need clarification on that.
Yeah,
at least I feel like exactly.
Okay.
The while loop.
Okay, let's see this video. I think it will put more light.
Can I just try and explain a little bit?
Yes, please go ahead.
So what's happening is if n is even, what it means is that let's say for example, that means you have to multiply 2 5 times and square it. You get? So for example, you are doing 2 raised to power 10. You can do 2 raised to power 10 or 2 raised to power 5. That's 2 raised to power 5. Then multiply it by 2 raised to power 5 again. So you can do 2 raised to power 5 raised to power 2. So in this case, what you are doing now is that you are splitting the numbers into 2. If it's even, it will split it into 2. So it will be like you are doing 2 raised to power 5. Then you now do it again times 2. Raised to power 2 again.
Twice.
Yes, just 2 raised to power 5 twice. That's what you are doing. So if it's even, so that's why you are doing that division there. You are skipping. You don't really need to do all of them, since you are just going to do half of it, then raise that one to the power, raise it to power and square it. So
I
that's it.
see what you're saying.
So if it's now odd, then you just do it normally.
So you're using the product rule. You're taking advantage
Yes.
of the exponential product rule to cut the
Yes.
problem. Okay, I get you. That's smart.
I think Harp is our math genius.
I'm not saying
Nice work. Yeah, that's thank you so much for putting so much light. There is a video that maybe explains same thing. Let's take a look on it and then we move to the next problem. Okay, let's go. Let me put the volume on and let's see.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve power of x to the power of n, or however you want to, say this title. And before we solve this, I just want to mention, so there's a ton of dislikes on this, but to be honest, I do feel that this is a pretty fair question. I think this is actually one of those rare medium problems that you can solve even if you haven't seen the problem before. You can mostly solve this problem. It's a little bit more tricky, I guess, if you want to, x to the power of n, well, we could have 2 to the power of 10, or we could have 2 to the power of negative 10, because actually in this case, n can be negative, even x can be negative, and actually x can even be a decimal, but that doesn't really change the problem actually. Like, 0.5 to the power of 10, it doesn't really change the problem because the math works out the same. The power itself can't be a decimal, right? We can't have 10.5. That would make this problem a little bit more difficult, but we actually don't have to deal with that case. So I do feel that this problem is mostly doable. It definitely does need a little bit of math background. So if you don't like math, yeah, you might not like this problem. But let's just refresh ourselves. So let's take a look at this first example, 2 to the power of 10, right? So what exactly does that mean again? Do you remember from your high school, middle school, college math or whatever? Well, 2 to the power of 10 is just basically a short way of writing 2 times 2 times 2, all the way 10 times basically, right? We'll multiply 2 10 times. So when you think about it, this problem sounds pretty dang easy, right? We could apply the same logic to the second example, 2.1 times 2.1 times 2.1, right? 3 times. Okay, but what about negative exponents? You might not remember from your math class, but negative exponent basically means, the same thing. So in this case, 2 to the power of negative 2 is still 2 times 2, right? 2 times, you still do it the same number of times. It's negative 2, so we'll do it 2 times. Only difference is you actually take this number and then put it in the denominator, and you take 1 divided by that number, right? So that's literally just it. Negative exponents are literally just taking that big number that we take, putting it in the denominator, 1 divided by whatever that number we calculate. So now that you know the math behind this problem, it's pretty easy to solve this problem in linear time, right? Can you see why? Because we can just do a while loop, a for loop, whatever you want to do, n times, right? So time complexity is going to be n. We just take x, multiply it n times. Now, the problem is, and I'm guessing maybe this is why this problem got so many dislikes, I don't think this actually passes the test cases. Why doesn't it? Because there's a better solution. it's not a common sense solution, but it is something that you can logically figure out. So if we're taking a number x or 2, whatever you want to call it, multiplying it out 10 times, is there a shorter way to do that? Is there a, I don't want to, ruin the problem. So if you want to try to figure it out on your own, go ahead. But I'm going to mention the key word right now. Is there a divide and conquer way that we could solve this problem? So here we have 2 times 2 written out, I think 10 times, right? So is there any repeated work you're noticing? Well, when the way math works out, multiplication, isn't it true that we don't have to do this 10 times? We could just do...
Okay, this is what we did, right? We keep looping on like each one of them. Let's see if this divide and conquer, how it works.
Do it 5 times, right? 5 times, half of it, right? Just do half the work. And then, once we calculate this number, which in reality is 2 to the power of 5, can't we just then say, okay, we have that number, 2 to the power of 5, and then just multiply it by itself? In that case, we're eliminating half the work. Yeah, we can do that. But why stop there? Can't we also further break this down as well? Well, we can't divide it by 2, so it's going to be a little bit more annoying, but we can say that. And actually, let me rewrite this to say, okay, this equals 2 to the power of 10, right? That's the result we're looking for. Okay, so then how do we get 2 to the power of 5? Well, you can say, take the exponent and divide it by 2. Well, we get 2 if we round down, right? We're going to do integer division. 5 divided by 2, what's that going to be? That's going to be 2, right? So what's the equivalent way to write this by kind of eliminating half the work? Well, we could say 2 to the power of 2, right? We could calculate this value, multiply it by itself, right? But this is just 2 to the power of 4, so we're going to need one last 2 value here, right? So we still did eliminate half the work, and then we just had a constant value here, right? This is a constant value, isn't it? There's no exponent over here, so this is going to be easy. And then here, cutting the work in half. And we can keep doing this, right? 2 to the power of 2 is just 2 to the power of 1 times 2 to the power of 1. And yeah, that is pretty much the entire logic of this problem. It's not too complicated, is it?
Okay. I think we get it now, right? I think this is what that's called doing. Right? Or I'm wrong?
Absolutely.
Yeah, pretty much.
It's like it just splitting
correct.
it. Splitting it and then, yeah, wow.
Wow, indeed. my friend.
Amazing, bro. Okay, I need to start some playlist, like some maths playlists, and like hopefully the end of this year I can be like better.
I'm not going back.
I am not going back. Oh my god. Okay, let's continue. Let's see this genius needs code.
Yeah, that is pretty much the entire logic of this problem. It's not too complicated, is it? The one thing to keep in mind, though, is what is going to be the time complexity. Is it still going to be linear? No, because suppose we had a exponent n, and how many times can we divide this value by 2 until it finally equals 1? Well, if you're familiar with what logarithms mean, that's basically the definition of a logarithm, right? How many times can we divide a number n, or let's say x, right? How many times can we divide a number n by 2? That's the base of the logarithm. How many times can we divide it by 2? Well, this is the time complexity, right? This is what that value is going to be. Overall, this is the big O, time complexity. If you're familiar with logarithms, you were probably able to recognize that immediately. If not, hopefully you can see it sort of right now. And the last thing is, so since we are doing this with a divide and conquer approach, it's gonna lend itself to recursion. Right? Because when we're trying to solve this problem, 2 to the power of 10, we can't solve it, right? We have no idea what it is. So we're going to solve that sub problem, right? 2 to the power of 5 first. Once we solve this, then it's easy to calculate 2 to the power of 10, right? Because we can just take this value and multiply it by itself, and then we'll get the result we're looking for, right? So this is going to be like a recursive chain. It's not like a double tree, right? It's not going 2 ways. It's literally just a chain of recursion. And then finally, when we get to our base case, suppose we had a base case down here somewhere, then we're going to be done. Then we're going to start popping back up each layer of that recursive, whatever tree or whatever you want to call it. So that's the main logic. But one thing with recursion, you don't want to forget is the base case. You don't want it to run forever. So what's the base case with exponents? If you ever raise a number, 5, let's say, to the power of 0, any number raised to the power of 0 is always going to be 1. So one base case for us is going to be if n equals 0, then return 1. Okay, so that's a good base case. Now, this isn't really a base case because x is never going to be modified, right? We're going to be dividing n by 2, but x is always going to stay the same. But if we ever got an input such that x was 0, can we raise the value 0 to any exponent? What happens if we raise 0 to an exponent? It's just going to equal 0 no matter what. So that's a base case. We can return 0, right? If we got an input such as 0 to the power of 10, we don't even need to do recursion. We don't even need to waste our time doing a solution. We can immediately return 0. So why waste our time? This is another base case. So these are the two base cases that you have to worry about. That's pretty much it. So let's go hop our way into the code now. And one thing I just realized is I didn't really mention how we were going to handle negative exponents, but like I mentioned at the beginning, x to the power of n is basically, or to the power of negative n, or if it's a negative value, is just equal to 1 divided by x to the power of positive n, right? So the way I'm going to handle the negative exponent case is I'm not even going to worry about negative exponents until the end. So regardless of what n is, I'm going to take the absolute value of it. If n is a negative number, we're not going to calculate negative numbers. We're going to calculate x to the power of positive n, no matter what. And then at the end, we're just going to take that value that we calculate and then say 1 divided by that. That's the easiest way that I can think of to handle it. You can do it differently if you want, but I'm going to show you how to do that now. So since we are going to handle it in that case, we're actually going to need to do like a wrapper. So this helper function is just kind of a wrapper so that we don't ever pass a negative exponent into it. So we're going to pass the exact same variables x and n. And then once we're done, so let me just show you how I'm going to actually call this function. So we're going to call our helper function, right? We're going to pass in x. X can be whatever it wants, but n is the exponent. We never want to pass in a negative exponent, so I'm just going to take absolute value of n and then get the result of whatever it was, right? But now, before we actually return the result, what if n was negative? Well, first of all, if n was positive, then we can just go ahead and return the result, right? So if n is greater than or equal to 0, then we're going to go ahead and return the result. Otherwise, if it's negative, if the exponent was negative, then we want to say 1 divided by the result, right? That's the main, just the math behind it, right? And now we can get into the recursive function. What did I mention a couple minutes ago? It was the base case, right? Remember, if x is 0, then we are going to be returning 0, right? Because it's going to, no matter what exponent we have, x, the expression is going to be 0. The other base case was if n is equal to 0, meaning the exponent is equal to 0. If that's the case, we are going to return 1 no matter what, right? Any value raised to an exponent of 0 is always going to be 1. So now we can actually get into the logic. So we're going to call our recursive function. So we're going to call the helper, and we're going to pass in x. X is always going to stay the same, but remember the n, the exponent is going to be divided by 2. So integer division, right? So you're probably thinking, okay, if we had n is 4, right? It's an even number, then we divide it by 2, then n is going to be equal to 2, right? But what if we had a odd number? Right? What if we had n equals 5? Then if we divide it by 2, n is going to end up equaling 2 in this case, right? So we have to handle that because if we, if it's an odd number, we have to handle it slightly differently, right? If it's an odd number, we have to multiply it by x one more time, right? Because x times x to the power of 2 times x to the power of 2 is going to be equal to x to the power of 5, right? Because the helper is what's going to calculate x to the power of 2, and then we're going to multiply these two. We're going to multiply the value by itself, and then we're going to have one more x at the end. Let me show you without actually, I might as well show you what we're talking about. So we're going to get the result from our helper. We're going to take result and multiply it by itself, and then before we return the result, we're going to say, don't just return the result, return x multiplied by the result if the exponent was odd. How do we know if the exponent was odd? Well, we can say if n modded by 2 is non-zero. So if this is the case, we can return x times the result. If it's not the case, that means we had an even exponent. That means we can just directly return the result, right? We just we took the result of this, right? And then we multiplied it by itself, and then we can return that, right? That's the entire problem. That's all the logic. Let's submit it, make sure that it works. And as you can see on the left, yeah, it's pretty efficient. It's about as efficient as you can get. There's one little trick I guess I'll show you. Probably most people won't care about it, but you can get rid of this line. If you remember from algebra, you know how exponent multiplication works and stuff like that. Instead of passing an x here, we can actually pass x multiplied by x, and then we won't need that line of code that I had below. So this will basically return, x to the power of n divided by 2 multiplied by itself. The wording might be confusing, but the math is consistent, right? The math does work out. I'll run it to show you that it works. As you can see on the left, yes, it does work, and it's slightly more efficient, but I don't think that's really necessary. That's just if you kind of like algebra and, want to do something fun. Hopefully this video was helpful. If it was, please like and subscribe. It supports the channel a lot, and hopefully
it was helpful. Subscribe it. Okay, that was good. It's same technique that we discussed. Any thoughts, or we move out to the next problem? Ooh. So, what's gonna be next problem? So we could say the square, but we can jump to geometry and see this problem. Rectangle overlap. But before that, let's read a bit about geometry. So geometry is a branch of mathematics that is concerned with property of space that are related with distance, shape, size, and relative position of figures. Advanced geometry, example 3D geometry, is not taught in most computer science courses, so you can expect that you will only be asked on 2D geometry. In algorithm interviews, geometry is usually not be the focus of the problem. You are not being evaluated on mathematics after all. You typically have to use other algorithm or the data structure in the problem. Zero values. This is all we get, people. So let's see just quickly geometry. Where are you, geometry? Here we go. Okay, so zero value. In the context of geometry problem in algorithm interview, zero value refers to case where one or more of the parameter or dimension involved in the problem are zero. This case can often lead to unexpected behavior if not handled correctly, which is why they are referred to as corner cases. Okay, we have it in mind. Let's keep going. So technique, there is 3 technique: distance between 2 points, overlapping circles, overlapping rectangles. Let's see them. So technique, distance between 2 points, distance between 2 points. This is the formula. X, so the first point x1, y1 and x2, y2 in a 2D space can be calculated using the Pythagorean theorem. Okay, is this something? However, if you are just comparing distance, you can skip the square root of operation to save some computation. Okay, I can skip that. Okay, let's see what is this quickly. Oh, ooh, okay.
Yeah,
okay, so this is
triangle, Pythagoras theorem.
Okay, so this is how you calculate the size or like the space of rectangle? EBC.
The distance of the hypotenuse, I believe. The longest side of a right angle triangle.
Yeah.
Okay, good to know.
I think I just said it too.
So if we're like just calculating distance between 2 points, we don't need the square, we can just skip it. Okay, the overlapping circles. Two circles overlap if the distance between their center is less than the sum of their radius. Here, how you can check this. So center distance, then how to, okay.
This is giving me flashbacks of a less happier time.
Okay, circle 1, circle 2, then we add it here, radius sum, and then we compare if this sum. Okay, the document you have it, guys, you can take a look on it more deeply. But okay, we are aware this stuff exists. Okay, this technique exists. There's other technique overlapping rectangle. There's it. Now let's see how we can solve this Let's code. Let's just brainstorm. If we're able to solve it, we can. If not, we can watch video about it. There's no problem. The answer of this question also, you're gonna find them here. So let's see rectangles. Let's go. Let's see what we have here. So an axis-aligned rectangle is represented as a list, okay, where x and y is the coordinate of its bottom left corner, and x2, y2 is the coordinate of its top right corner. Its top and bottom edge are parallel to x-axis, and its left and right edge are parallel to the y-axis. Two rectangles overlap if the area of their intersection is positive. To be clear, two rectangles that only touch at the corner or edge do not overlap. Given two axes, align rectangles rec1 and rec2 return true if they overlap, otherwise return false. So this is rectangle 1, rectangle 2. We need to say if they're overlap. Now,
I guess to give the formula.
yeah. They need to give a formula, or you mean we need to give?
No, I guess they gave a formula. I saw when you were opening something. I saw the rectangle overlap.
Yeah, this one I think. Yeah. That's how we can like understand it. Someone talking. Okay, me. Your mic is open. Okay, we can.
You can maybe map the Cartesian coordinates so
yes.
we can understand it.
Okay, let's go. Let's put this with us. And then we put this.
Yeah, that's an easy one to draw. It's all positive.
So now which one is okay? So let's say this is rectangle. I'm joking. Okay, so this is rectangle. So 0 is xy, and
oh, you didn't draw it correctly, Mansif.
I think you should draw a plus.
Wait, like how?
Like
this?
Vertical line. Like a large plus.
Let's do this. Let's draw an XY coordinate.
Yeah, that's the plus I'm thinking of.
Yeah.
So,
0, 0 at the corner there. And
okay.
then the Y only goes to a maximum of 3, I think. and the x goes to a maximum. Let's just say they go both to a maximum of 3. So
but like
starting from the 0th corner.
isn't that the same like this?
No, that's a triangle.
Oh, that's a triangle.
We're
Okay,
drawing the coordinate map.
oh, okay. So I am like actually thinking we are doing triangle. Okay, okay. Let's see. See, I'm learning. Let's go. So
Okay, so we're drawing the map in which we're going to be drawing the other things, right? So
so
that
this
corner will
is
be 0, 0.
and 2, 1, 2, 1, 2. So this one, right?
No, it starts at 0, 0, and then it goes to 2, 2. Yeah, so you draw the map now from it.
Yeah, so like this is 0, 0, and this 2, 2.
Absolutely. Now we can draw the rectangular representation of that.
Okay,
so
wait.
you can fill in.
I'm confused. What is like a rectangle?
It's a square, but not equal sides.
Okay, let me just imagine, because when I hear rectangle, I imagine triangle.
لا مستطيل.
Okay, okay.
For angle.
Okay, I'm not faking it, by the way. I swear I don't know. Okay.
Don't worry, bro.
It's just like English word.
Okay, so you see they give you 4 points, right?
Yes.
The first point.
Why not label it like the numbering? The x axis.
Yeah, okay, so 1, 2, 1.
No, let's label it like they labeled it in the question. So you check in the question there's x1, y1, and then x2, y2. So the first value is x1. So on the x-axis, let's find the 0 point will be that one, right? So that'll be x1. And then x2 would be the third value in that thing, so it'll be 2. And then y will be 0, right? So it'll be exactly where the other x is there, but the y2 will be at where y is equal to 2. So then from those 4 points, you can then draw your rectangle shape.
Oh, I see. Okay, so this is x2, y2.
No, not exactly. That's for the second rectangle. So you see the first rectangle is represented by those 4 points.
Okay, wait, I'm confused. So this is x, or like xy?
x1, y1.
Okay.
So just proud.
Okay, so 1, 1, x1, y1. Y2, x2, y2.
You can notice. Okay, you can notice by x1.
3 and 3 is like this. It's gonna become x2. And y2. Is it correct?
Is that x0?
You're getting it, but you know that there are 2 rectangles. One is rec 1, the other one is rec 2.
Okay, so like this is 1 and this
that's
is
1,
2.
then the other one is rec 2. So x1, y1 of rec 2 is 1, 1. Then x2, y2 of rec 2 is 3, 3. So for rec 1 is 0, 0, 2, 2. Like that. So x1, y1, 0, 0, x2, y2, 2, 2.
Okay, is there something wrong there?
No, it's okay, you're correct. It's just the labeling that.
The labeling. Okay, how do I label them?
Yeah.
Because x1, so I do 3, 4 maybe. I think it's better.
So for that,
you can do it by 2 coordination. X.
It will be better if you can use two different colors for the 2 rectangles.
Okay. So let's do this one blue. And we use blue color for this one. So this one gonna be...
Yeah, that works.
Okay, so this one is x, 0 or like x1, we're gonna call like this says 1 2 3, so x3, x3, and this one gonna
No.
be y3.
Why?
What?
No.
What?
You know we have two rectangles.
Yeah, so like this one is x1, y1,
And x2.
x2,
x1 and y1 and y2.
y2. So this is
For that
one
rectangle.
rectangle. This is the same one, right?
Yes.
Yeah.
Yes.
And this one, I'm just saying like we do like x3,
No, you
y2.
can
No,
you
now
can
be
just write
x1,
it by
y1 again.
different color.
No, he's saying in order to differentiate between them, right? Because the first rectangle takes up x1 and x2, let the second triangle take x3 and x4.
You know what I
Then
mean?
y4 and
Okay.
y3.
So-
Which is fine.
Okay.
3.
And then this point is gonna be like what x4, y4. Now the green one, it's gonna be x0 or like 1, and the y1, which is 0 0,
Yeah.
and x2 and the y2. Finally, let's go. Okay, so now this is, they are overlapping here, right?
Yes, sir.
So we can detect this line if, or like let's see, let's try to understand this.
Remember when we did the overlap? I think it's something
Exactly.
similar to that.
That's what I wanted to say. If you can find a number that is in the range within the first rectangle, like one, you have one there, it's within the first one, I guess that's what you can say it's overlapping. Just a guess, anyways. I know they have a formula though, but I just feel that since you have one in the second rectangle, definitely it's within the range of the first one, definitely is overlapping. That's how I see it.
Okay, how we can like do that, like in the code, like we can see this, it's the same, I guess. It's just comparing each. So rectangle A, rectangle B, left, right, right, left, top, bottom, and bottom, top. So this is left, this is right, left, right, top, bottom. So left should, if it is less than the right, so left less than the right, less, and check again, right greater than the left, right greater than the left. Okay, so this is the interval, right? We did same condition at the interval, if you remember, right? We check this, if this less than this, and then if this greater than this, that means they are like overlapping. But we should also check the top. So top of this is greater than this one.
No,
Oh, sorry, the bottom. Greater than the bottom, and the bottom of this one is less than the top. Okay, I get it.
So what coordinates consist of the left side of the rectangle A? Let me ask that question.
Left A is this one. So this is A, and the left is right here. Sorry, right here.
Oh.
This is left. This is right. This is top. This is bottom. Right?
X1,
So that would be like x1, y2,
Y1.
y2.
So
So you
y2.
get like it will give you the
Is
full
it
range of
X1 or X0? Oh, okay, you
X1
use
now.
X1. Okay, first one, the first X. Okay, first X, Y, T, A. That's correct. So I'll let you just know the coordinates that makes up the left. So good.
Okay, in the code, what they give us? Rectangle int rectangle 2. So the code gonna be like we're gonna check rec1 left, which is what here?
Left,
x1
which is here.
x1. So it's gonna be 0. Let me zoom.
No. In this case,
It's gonna be index 0, right?
Exactly. Because
yes,
if you
0.
don't break it down,
0.
you'll be able to solve it. Nice.
Okay, that means we'll have to be looking in two planes, I think.
Exactly.
Either you're looking at the x value or the y value. Okay, for the y value is top and bottom, for the x value is left and right. So we can just use x1 and x2 for left and right.
x1 and x2, yes. So x2 is index, always gonna be in index 2. So 0, index 0 is left, index 1 and index 2 is right, index 3. So index 1 is y1, which means bottom, and 3 is top.
Yeah.
So we need to check this and check for rec1 right, which is 2. It should be greater than rec2. Left. What is left? 0. And we need to check for rec1. Oh, rec1. Top of rec1 is 3. Should be greater than rec2. Bottom we said is index 1, and rec1 bottom is 1, index 1. It should be less than rec2 top, which is 3. Okay, so this is our condition, right? Now we just need to do and to return. If to return true, it means there's overlap. If to return false, that means there's no overlap. Test it. Let's test it in our triangle. I mean our rectangle. Okay. Oh my god, I love math. Hey. I love geometry. Okay, return. I hope they don't have Pycode style, because this gonna be recheck.
Bet is gonna get you. This is more than 80 lines. 80 characters, sorry.
Okay, I don't know if you can do something like this. I think you can. Run. Hey, submit.
You are genius.
I am genius at geometry. Oh,
He's the
let's
genius.
go. Let's go.
Genius of our time.
Good job.
Great
Good
job, man.
guys. Okay, this is what
Let's not do maths again, guys.
this was the most hard topic. Was I couldn't skip it. We have to deal with this. But at least we know now. At least we know.
So you can,
Yeah, I know what I don't know.
Okay.
I think you can use this for collision also in games and the rest.
Nah, you ain't lying. You're not lying.
Yeah, it's interesting, but like if you keep learning just in what you're familiar with or like what you like, you're gonna miss a lot. But like sometimes you need to like take a lot outside of comfort zone. So basically, guys, congratulations for finishing 4 weeks. 4 weeks we study it all, we see it all. Now week 5, like week 5 starts, and now it's gonna be way easy because we finish all the topics, so we don't need to like to study topics. We just gonna jump to lit codes and try to solve them using what we learn in this 5 week or like 4 week. So week 5 gonna be warm up lit code. Then week 6 easy lit code. Then it's gonna start medium in week 7, week 8, week 9, week 10, week 11, and the last week of the 3 months where it's gonna be some hard lit code. Okay, let's see. Let's meet again same times next week and we try to go through this lit code. Maybe we're gonna do them all together, like H1, and then the first one finish, maybe share screen explain, or like just see like 2 or 3 solution for H1. Anything? Someone want to say something? And please, like, if you prefer, like if you did some of this lit code, like feel free to jump and like go through your solution and something. If that's all, I love you guys. I love this PLD, and let's keep growing together. Have a good night.
Thank you, guys. Thank you, everyone.
Yeah, thanks,
See you
guys.
tomorrow.
Thank you.
Hard things continues.
Next Tuesday. Tuesday. Okay. Have a good night, everyone.
Thanks,
Bye.
guys. See you later.
See you.